Welcome to Off by 1 squared. In this video, we'll examine a simple counting problem and see how it relates to the inclusion exclusion principle. First, let's imagine we're building a fence that's 10 meters long, and we place a fence post every meter. How many fence posts do we need to span all 10 meters? It's easy to see that if we have a single post, we span 0 meters. If we add another post, we can span 1 meter. So with 2 posts, we get 1 meter. To span another meter, we need another post. So once we have a starting post, then we span 1 meter for every additional post we have. So to span 10 meters, we'll need a total of 11 posts. 1 to start, and 1 for each of the 10 meters we're spanning. Now what happens if we want to enclose a square area that's 10 meters on each side? Naively, we might say that since we have 4 sides of length 10 meters, and we need 11 posts for each side, we would need 4 times 11, or 44 posts. However, a careful counting reveals we actually only need 40 posts. What happened to the other 4? Well, here we get to the inclusion exclusion principle. This principle, which comes from combinatorics, is a technique for counting elements in the union of multiple sets. In the case where we have 2 sets, A and B, we can count the number of elements in A union B by the number of elements in A, plus the number of elements in B, minus the number of elements that appear in both. Because if an element is in both, we counted it twice, so we need to subtract it once. How does this apply to our fence problem? Well, we can do this by counting the fence posts in 2 different sets that, individually, are easy to count. First, consider the fence segments that are horizontal, as shown here. We've already seen that each segment contains 11 fence posts, so for both of these segments, we have 22 fence posts. So far, so good. Now consider the vertical fence segments. Similarly, we have 22 fence posts here as well. However, notice that the segments overlap at the corners. We only need 1 post in each corner, and each corner is shared between 2 fence segments. Since there are 4 corners, we know that the number of elements that appear in both sets, or here, the number of fence posts that appear in both vertical and horizontal segments, is 4. Finally, we just apply the formula. 22 plus 22 minus 4 equals 40. Sometimes it's easier to count things by overcounting and then subtracting off what you overcounted. Leave a comment below if you can think of other examples where this is the case. And feel free to like and subscribe if you'd like more videos like this and other interesting math topics. Thanks, and see you next time.